So welcome back after that short 1 minute break. I think that was an Irish minute rather than an English one. Anyway, it's good to have you back, and it's a great pleasure now to introduce our next speaker on the subject of climate hacking, and he'll explain what that means. Professor Meric Srokosz, who's a professor of physical oceanography at the National Oceanography Centre in Southampton, with research interests in the ocean's role in climate, and he's involved in satellite oceanography and study of waves as well. And together with Rebecca Watson, he's authored the book Blue Planet, Blue God, the Bible and the Sea. So we're looking forward, Meric, to your talk on climate hacking.
Thanks very much. I've got the mic all set up, I think. Great, thank you very much. This has got very little to do with my book, I'm afraid, because we didn't really do geoengineering in the book. But if you're interested in the Bible and the sea, buy my book. Unfortunately, there are no copies here, but you can get it from Amazon. So, climate hacking. So that's basically geoengineering. I'll explain my terminology in a minute. I put up this picture because it goes back to the beginning of my research career. Does anybody recognize this middle picture? Wave power, yeah. So this is a thing called the Salter duck. In 1973, I started my PhD. No, I didn't. I started in 76. In 1973 was the oil crisis. Some of us are old enough to remember that. And in 1976, I started my PhD on wave power alternative energy, which has come back into fashion after a long time. And I'm finding the papers I wrote from my PhD being quoted, which is quite nice, 40 years on. So the reason I put that up is because that was this thing is called the Salter duck. It was invented by Stephen Salter. And in fact, this is also invented by Stephen Salter. It's a geoengineering technique, which I will talk about in the talk. It's about brightening marine clouds. The other area that I've had some involvement in is what's called iron fertilization, where you put iron in the ocean to make phytoplankton grow. Phytoplankton absorb carbon dioxide, etc. You take carbon dioxide out of the atmosphere. So this is an iron fertilization experiment. I wasn't involved in an experiment. I was involved in doing some more theoretical studies. Well, this is in the Southern Ocean, and people put in some iron, and the currents, the phytoplankton grew, and the currents sort of stretched it out into this shape. That's just a bit about my background. So the problem we're addressing is, sorry, I should have said next slide, I forgot. The problem we're addressing is, simply stated, we're not reducing our CO2 emissions fast enough from fossil fuel to prevent catastrophic climate change. That's very clear. Despite all the agreements, we're not actually doing it very effectively. So, next slide. The solution is geoengineering, or that's the proposed solution. In simple terms, it attempts to solve our climate emergency by applying technological solutions. So it's a technological approach to solving the climate problem. More formally, it's defined as the deliberate, large-scale manipulation of environmental processes that affect the Earth's climate in an attempt to counteract the effects of global warming. So here are some of the effects: heating, drought, hurricanes, fires, glaciers and ice caps melting. Next slide, please. So I've called this talk climate hacking because the question is geoengineering or is it climate hacking? Hacking in a sort of common usage refers to computers, and it talks about doing things that cause damage or corrupt systems. So will geoengineering cause damage or corrupt the Earth system? Hence, is it better described as climate hacking? So are we doing geoengineering, or are we really just hacking the climate? There's a website at Oxford University which goes into lots of details about geoengineering. I'm not going to cover everything in detail. This book was published, Hacking the Planet Earth, but this guy obviously thinks that geoengineering can help us reimagine the future. He thinks it's a positive thing, I think. Let's explore that in this talk. Well, that's my intention. Next slide, please. So what I want to do in this talk, I will look at what forms of geoengineering have been proposed. This is going to be a brief review because there's lots and lots of different proposals now. I can't keep up with all the proposals for geoengineering. Another question will be, do they work? So I'll have a quick look at the pros and cons of those. And what ethical issues do these geoengineering proposals raise? Because they do raise ethical issues that we need to address. And finally, I want to talk about a Christian perspective on geoengineering. Next slide, please. So we are trying to heal the earth. We've damaged the earth, and we want to heal it. It's not in a good condition, and it's going to get worse. The patient is ill. We need to make the patient better. So the obvious way to do that is to reduce our CO2 emissions. We need to reduce our CO2 emissions. Ultimately, that's the right thing to do, and requires the use of non-fossil fuel for our energy sources. Everybody agrees that's what needs to be done, but nobody seems to be doing it very effectively. And there are two types of geoengineering proposals that have been put forward to try and address this issue of healing the earth. There's what's known there's various terminologies: carbon dioxide removal, greenhouse gas removal, negative emissions technologies. That's one group of solutions. And the other group of solutions is solar radiation management or terrestrial radiation management. As you saw in Ewan's talk, basically have incoming solar radiation and outgoing infrared radiation, and the balance allows the Earth to stay at a reasonable temperature. And so these second group of geoengineering proposals are all about dealing with that radiation coming in or leaving the Earth. So those are the sort of proposals, and I'm going to go through all three areas. Next slide, please. So these are what are termed the conventional mitigation options. I'm not quite sure why they put carbon capture and storage and utilization. I would have put that in geoengineering. This is taken from this review by Fazwi et al. So I've just used their pictures rather than having to draw my own. So what we see here is that the standard things are renewable energy rather than fossil fuel energy, nuclear power, switching fuels like switching from coal to gas, making efficiency gains. So there's a whole range of things that we can do. Carbon capture and storage and utilization. So these are what they call conventional mitigation options, things that we should be doing or thinking about. And there are some obviously disagreements about nuclear power, because what do you do with the nuclear waste? The fuel efficiency switch and efficiency gains is good to a point, but doesn't actually stop you warming the earth entirely. Renewable energy is the ideal solution, but we're not very far down that route. I think at the moment, the global capacity for renewable energy is about 15% or something like that. It's reasonable, but it's not everything we need. And there are also security issues as to, it just struck me the other day, being a marine person, that we've got all these windmills in the North Sea. Somebody just needs to hijack a ship and sort of plough into them. It's not a very safe place to have a lot of windmills necessarily. So I think there are issues with even the standard conventional mitigation technologies. So let's move on to geoengineering proper. Next slide, please. So these are carbon dioxide removals or negative emission technologies. Basically, you're taking carbon dioxide out of the air, reducing the carbon dioxide in the atmosphere, and therefore reducing global warming. That's the plan. I'll start with the ones that I'm more familiar with, which is the marine ones. Ocean fertilization. Phytoplankton require nutrients to grow. There are macronutrients, which are nitrates and phosphates, but there are also micronutrients like iron. And a lot of the proposals have been about, there are places in the ocean called high nutrient, low chlorophyll, where there's lots of the big nutrients, nitrate and phosphate, but there's very little iron, like in the southern oceans. And the plan is to put iron into the ocean, encourage plankton growth, take up CO2, get that trapped in the ocean, and hopefully sequestered eventually either in the deep ocean or in the sediments. There are problems with ocean iron fertilization because we don't really know what the effect on the ecosystem will be long term, and whether you can actually dump enough iron in the right type of form that can be used by phytoplankton is debatable as well, but it's a thing being considered. Ocean alkalinity enhancement. Again, you need to dump a lot of alkaline stuff into the water, but that allows the water to absorb more carbon dioxide. And this has the advantage of reducing the problem of ocean acidification due to carbon dioxide removal, carbon dioxide absorption by the ocean. So that's another proposal. I think that's less developed than the ocean iron fertilization one. Moving on to the ones that I'm less familiar with because I'm not a terrestrial person. Afforestation and reforestation. Afforestation means growing trees where there aren't any now. Reforestation means regrowing trees. Trees capture carbon dioxide from the atmosphere and trap it in the trunks and in the leaves. And the problem is that they only do that when they're growing initially in their fast-growing phase. Once the tree reaches maturity, it's probably neutral with respect to its carbon dioxide capture from the atmosphere. There's the idea that you would cut down the trees and do pyrolysis, which is basically you heat them to a very high temperature, and what you get left with is biochar, which is basically carbon, and then you can bury that in a little gland, and that actually helps with growing things in the land. So that's one proposal. Soil carbon sequestration is you change your crops and change how you do your farming, and the soil actually does absorb carbon, so you can increase the amount of carbon absorbed by the soil or by things growing in the soil. Bioenergy and carbon capture and storage, which is called BECCS. Basically, you take your energy from things like trees to produce energy, and you capture the CO2 and stick it somewhere, possibly in a reservoir under the ground. Enhanced terrestrial weathering, basalt interacts with carbon dioxide and forms inert chemicals. So the idea is there you would pulverize a lot of basalt and expose it to the atmosphere, absorb the carbon dioxide, and then spread that over the planet into fields and things, because it supposedly helps with growing things. And then the one that's quite trendy at the moment is direct air carbon capture and storage, DACS, where you actually capture the carbon directly out of the air and then you store it somewhere. I'll talk about that a bit more, because that's the trendy one at the moment, as can be seen by the fact that there was a recent Guardian article on this, in fact just last month in September. So this is climate crisis. Do we need millions of machines sucking carbon dioxide from the air? So, this is a proposal, serious proposal, to actually suck carbon dioxide out of the atmosphere and store it. And millions of machines. So this essentially works by drawing air into a box, in simple terms, through a fan, and then you have a filter that captures the CO2. It either absorbs it or adsorbs it. There are different ways of doing this. And then once the filter is full of carbon dioxide, you close off the box, you heat it to a high temperature, which releases the CO2. You then take that off, mix it with water, and pump it into basaltic rock, and it turns to stone in about 2 years. So there are actually people building such systems at the moment around the world. In fact, I think there's one actually operational in Iceland currently. One thing that I forgot to mention on the previous slide, but I'll go on to the next slide, please, is blue carbon. So blue carbon's very trendy as well. So the idea of this is that you store the carbon in coastal and marine ecosystems. Currently, this is focused on coastal systems. Mangroves, tidal marshes, and seagrasses, they do absorb an awful lot of carbon when they grow. And there's lots of places where people are trying to do mangrove restoration, because it actually has advantages in terms of protecting the coast from storm surges and waves and so on. So there are people doing this. The main problem with this is, as you can see on this map, the places where you can actually do this is rather limited compared to the size of the planet. So there's a limited possibility of doing this type of blue carbon capture, but it's also something that's being done currently. So these things that I've talked about so far, they're all carbon dioxide removal or negative emission technologies. They're basically taking CO2 out of the atmosphere and trying to put it somewhere. How am I doing for time? I have no idea what I'm doing in terms of time. Okay, so the other one is solar radiation management. So you've got sunlight coming in, and there are various ones. I think this was one of the first proposed by Paul Crutzen, who's a Nobel Prize winner. Mount Pinatubo in 1991 erupted, putting sulfate aerosols high into the atmosphere. Over the next couple of years after the eruption, the planet cooled by about 0.5 degrees because of the extra reflective aerosols in the high atmosphere. So the plan is you send up planes at high altitude and you put sulfate aerosols into the atmosphere, and that reflects the sunlight. You put in big mirrors somewhere between the Earth and the sun, and you reflect the sunlight. Surface brightening is you paint all your roads and buildings white, which increases the albedo of the Earth, and that reflects the sunlight. Marine cloud brightening, marine sky brightening, which was what Stephen Salter, who invented the Salter duck, proposed. You basically spray seawater into the air, And as the droplets evaporate, they leave behind little particles of salt which form cloud condensation nuclei, and that causes extra cloudiness over the ocean, again reflecting the sunlight. Cirrus cloud thinning, I don't quite understand that one. I don't quite understand how that works, so I'm not going to say it. But the idea of that is to let more infrared radiation out by reducing the amount of cirrus clouds at high altitude. So, does geoengineering work? I mean, that's a basic question. And one key issue is scalability. So there's lots of these proposals being made, and lots of people have demonstrated some aspects of them on small scale. But the question is, can you implement it on a large enough scale to actually make any difference to the climate problem? Because you need to take a lot of carbon dioxide out of the atmosphere, you need to reflect a lot of sunlight if you're going to make a significant difference. And it's very unclear at this time whether most of these methods or any of these methods can actually be scaled up to the scale that you need to do geoengineering seriously. Many of the methods, like the one I described, the direct air carbon capture and storage, require you to take carbon dioxide out of the atmosphere, capture it, then you need to heat it up, and then put it in the ground. So you need energy to make it work. So there's this balance between how much energy do you need to make it work, and where do you get that energy from in a non-CO2 fashion, and the actual amount of CO2 that you're removing from the atmosphere. And it's not very clear on some of these what the, people have tried to make estimates, but it's still not clear what the balance is. I mean, the Climeworks DAX plant in Iceland. Iceland's a great place for this in the sense that you've got all this geothermal energy. It's got one of the largest aluminium smelters in the world, and the reason for that is because there's got lots of geothermal energy to smelt aluminium. And the same with this DAX plant. You could put it in Iceland because you've got lots of free energy, non-CO2 producing energy. But whether you can produce enough energy to do all these things, because they all require energy at some level, if you're going to take your forest and apply pyrolysis, which is basically heating the trees and reducing them to biochar, you've got to get that energy from somewhere, and it's not clear where you're going to get that from. And then there are unintended consequences. For solar radiation management, if you change the distribution of sunlight on the Earth, you immediately have a problem because the sunlight determines our weather and climate system. So if you change the distribution of sunlight, you're affecting the weather patterns. So it may start raining here or being drier here, or there's all sorts of consequences which we don't understand. People have done models of this, and I think models disagree, depending which model you use. I noticed a few modelers in the audience recognizing these issues. So there's an iron fertilization, which is the one that I'm familiar with. We dump all this iron in the ocean, so the phytoplankton grow. That has an impact on the zooplankton, that has an impact on the fish. It's a whole ecosystem impact. And it's not clear what that will do to the ecosystems long term, even if you can dump enough iron into the ocean. Can you tell me what time I'm supposed to finish? Because I've forgotten. 10 minutes, okay. Next slide, please. Geoengineering also raises ethical questions. Should geoengineering be considered at all? Potentially, it encourages an irresponsible attitude to future fossil use. If we think we can sort of solve it by geoengineering, we just keep using fossil fuels. I think this is called the moral hazard argument. Basically, the idea that, well, we can solve it, so we'll just carry on the way we are. Who decides which geoengineering approach is safe to use? Might be right. Will the rich and powerful impose things on the poor and needy? The Bible has quite a lot to say about the poor and needy, so from a Christian perspective, that's something we should think about. So, yeah, I've said that, particularly the poor. And should a country pursue one of the approaches unilaterally if it will affect people elsewhere? There are some people, the United States has the technology to put mirrors in space, but should they do that unilaterally? Is that the right thing to do? People at Oxford, next slide please, put together a bunch of principles, I'm not going to read through them, to try and pin down what needs to be done if we're going to pursue a geoengineering option. And so they came up with these principles as to how this should be approached. I don't think anybody's agreed to these, but they came up with these principles. Next slide, please. I see it as a political nightmare. I mean, I can't see how anybody's going to agree about what we should do, because any large-scale solution is going to have an impact possibly elsewhere in the world. So if you do things, particularly with the solar radiation management ones, You're going to change weather patterns. You can have catastrophic runaway warming. Suppose you've got all these mirrors in space nicely reflecting the sunlight, and an asteroid zips through and destroys them all. Suddenly you've got no mirrors in space, so you go from a situation where the CO2 is still in the atmosphere, you're no longer cutting out the sunlight, you could have runaway catastrophic global warming. The same is true with the carbon capture and storage. If you're pumping liquid CO2 into old oil and gas reservoirs, which is what has been proposed, suppose that oil and gas reservoir breaches and all your CO2 suddenly escapes into the atmosphere in one big burp, then you could again have runaway catastrophic global warming. There's the go it alone problem. Some people might just go in and do it. And it doesn't really solve the problem of us emitting more CO2 into the atmosphere. We've already had problems with the go it alone. These are a couple of things from nature. People have actually gone away, despite there being a moratorium on dumping iron in the ocean for these sorts of purposes, and gone away and done it anyway. So there are people out there who'll do it and don't care very much. Next slide. So Professor Michael Mann, you may have heard of, hockey stick graph. Who's heard of the hockey stick graph? Temperature graph. Yeah, very famous temperature graph. Got into all sorts of trouble with the climate deniers with the hockey stick graph. So he talks about this, but the thing he talks about, he says, direct air capture seems the safest and most efficacious, along with natural reforestation. It could be an important component of broader efforts to draw down carbon from the atmosphere, and possibly should be used. But since we're only talking about capturing 10% at most of current carbon emissions, this is obviously not a primary strategy for cutting emissions. So basically, although you could do some of these things, even with the best solutions, you're not going to capture most of the CO2 in the atmosphere. You're only going to capture a small amount of the CO2 in the atmosphere. Another quote from a scientist at Berkeley Earth. Current global capacity for DAC is about 12,000 tons of CO2 per year. Each year, human activities release about 40,000 gigatons anyway. So right now, DAC is like trying to bail out the Titanic using an eyedropper. You know, it's seriously not a serious solution. There's no way we can do this. In 2020, I should note that our emissions went down to 31 gigatons, just because of the coronavirus crisis. So I've sort of set out what the issues are, and I just want to finish up by thinking about a Christian perspective. So I'm not sure there is a single Christian perspective, so this is my personal perspective, my thinking on this issue. It stems from two papers I wrote. One is using the biblical meta-narrative as a basis for our environmental thinking, and another one about geoengineering and plan stacking, which I think the theological part of this is okay. I think the geoengineering part, there's been many, many more proposals about geoengineering since this was published in 2014, which is why I used the Fazwi et al. Paper, because I've lost touch a bit with, it's diversified in so many ways, it's difficult to keep up. But my thinking is based on these papers, so if you're really interested in more than you can hear today, go and look at the papers. Next slide, please. So I have two starting points in my thinking. One is about the need to think and live eschatologically. We as Christians are living in the light of the future. God has a plan for us and the planet, a new heavens and a new earth. That's where we're going. That's what God's plan is. There will be a new heaven and a new earth. And how do we live in the light of that truth as Christians? That's one starting point. The other starting point is, I like to go back to basics, and you can't get more basics than obeying Jesus' first and second commandments, which is love God and love your neighbour. That's about as basic as you can get for a Christian. And I think that's a good starting point for us to think about some of the ethical and other issues associated with geoengineering. Next slide, please. So looking at an eschatological perspective, let's take an analogy. In the new creation, we'll all be healed. No more pain, no more suffering, no more death. So in the present, using medicine and prayer for healing, we are anticipating the new creation, that perfect time of healing and wholeness, by what we do in the present. In the same way, we can think about healing God's earth. It is God's earth, after all, in Psalm 24, verse 1. And we can anticipate the new creation by caring for both the earth and the people on it. So I think that's one of my starting points. We are anticipating the new creation if we try to care for the earth and the people on it. And we actually pray this regularly if we pray the Lord's Prayer. Your kingdom come, your will be done on earth as it is in heaven. We're anticipating God's kingdom. We are seeking to see God's kingdom come in the here and now in anticipation of what will be in the future. So on that basis, I sort of come to this sort of conclusion about the eschatological perspective. If geoengineering is likely to become an excuse for not caring for God's earth and an excuse for us to continue to misuse and harm the earth, then it shouldn't be considered at all. If we are going to carry on the way we're doing and not do anything, not to change our lifestyle, not to change our consumerism, not to change the amount of CO2 we're pumping into the atmosphere just because we think we've got a technological fix, then I don't think as Christians we should even consider that. We should consider about changing our lives and our lifestyles rather than looking for a technological fix that allows us to carry on misusing God's creation. So is geoengineering like to heal or harm the earth? Are we anticipating the new creation? Are we anticipating a renewed, healed, complete creation in what we're doing? So from this perspective, solar radiation management approaches to me are less acceptable from my Christian perspective than our carbon dioxide removal ones, because what we're doing is we're treating the symptom, the heat, the temperature, rather than the cause, which is the CO2 emissions. So I have problems with some of the geoengineering from the point of view that it's like we're sticking a plaster over a problem rather than making sure that the problem is healed properly. So that's my eschatological perspective. First commandment perspective, you shall love the Lord your God with all your heart, all your soul, and with all your mind. So I like these quotes from Christopher Wright, who's an Old Testament theologian some of you will have come across. Trashing someone else's property is incompatible with any claim to love the other person, and our treatment of the earth will be a measure of our relationship with the Creator. So is geoengineering compatible with caring for God's earth? We are here by God's grace. It's His planet, not ours. Are our actions caring for what He's given us to look after, or are our actions causing problems? And I think some of the geoengineering proposals, from my perspective, would seem to be not viable from that perspective as a Christian. And then finally, the second commandment, you shall love your neighbour as yourself. I think this is perhaps the decisive commandment for Christians in evaluating geoengineering proposals. And the reason I think that is God has a special care for the weak and the needy of the earth, and they're the most likely to be harmed by some of the things that are being proposed. So, like solar radiation management. So we need to think carefully as to whether geoengineering is a good way to go in terms of caring for the weak and the needy of the earth. And I remain to be convinced about that for many of the proposals. Not necessarily all of them, but many of them. For example, solar radiation management and changes in weather patterns. We're already seeing the consequences of changing weather patterns due to global warming. If we start messing with solar radiation management, you've got problem A, you do B to solve problem A and cause problem C, which is worse than problem A in the first place. We don't really know what we're doing. There are unintended outcomes. Hubris view humility is a question we should ask ourselves. And I think, to me, a lot of Scripture is about other-centered ethics. It doesn't center about what I'm about or where I'm at. It centers about what other people need and how to meet their needs. And as Western, rich Christians, maybe we need to be thinking about the poor of the world a bit more than we do at times. It's very easy to get isolated from that challenge because of the lives that we lead. Going back to the 1980s, there was a book called Rich Christians in an Age of Hunger, written by a man called Ron Sider. And I think the church in the West failed to take seriously the message of that book in the 1980s. We got Reaganomics and Thatcher. I think that we need to be careful that we don't miss what God is saying to us now about caring for the poor and needy of this world. So, geoengineering or climate hacking? Let's conclude. So my view at the moment is none of them have been proved to be able to work on a large enough scale. You go back to the eyedropper bailing out the Titanic problem. Can we actually do this on any scale that will make any difference? Some seem relatively safe in the sense that the more natural ones, if you grow trees or restore mangroves, you're unlikely to do serious harm to the planet. But even then you have to be a bit careful, because I think mangroves, if I remember what Ewan said, that sort of thing may produce methane. I can't remember I'm not an expert on this, but tidal flats and things produce methane, don't they? So there may be some other things that you need to think about. Even the natural ones may not be, you may not. Mangroves aren't too bad. Okay, well, that's good. Well, we should go plant more mangroves. There's a limited number of places you can plant mangroves. So even forestation and reforestation are a problem, because if you grow trees in places where there haven't been trees, you're changing the albedo of the planet, which may mean you're absorbing more sunlight. None of it is straightforward. Some have potential to cause problems, and I think solar radiation management is the one that I worry about, because people seem to love that idea of spraying particles into the stratosphere or putting up big mirrors in space, because it's really clever technology, but I'm not convinced. And there are ethical problems. Perhaps the safest course is thinking about the medical analogy is the one that doctors do no harm. We should think about doing the least amount of harm, so avoiding exposing people of the earth to additional risks through our actions. So just to finish, from my Christian perspective, I said from a Christian perspective, it's my Christian perspective, you may disagree. Too much of what is being proposed seems like climate hacking to me rather than geoengineering, and suffers from hubris. It's the idea that we think we're not as clever as we think we are. We think we're quite clever as people, but we're not really. We've screwed up a lot of the earth over the years, and I think a bit of humility is required before you go down some of these routes. You can be all gung-ho about come up with this new idea, clever technology, and I think a degree of humility is required. So key questions to me are, will geoengineering harm people on the earth, particularly the needy and the poor? Will it harm the earth itself, or will it heal the earth? Will geoengineering anticipate the new creation? Are we going to, in what we're doing, are we seeing God's kingdom come? Are we seeing the new creation, working towards that new creation in our actions? Next slide. Oops. Yep. I think that's it. Thank you very much. Questions?
Meric, thank you very much indeed for a very illuminating talk. And I've got a really controversial question to ask you, but I'm going to claim chairman's privilege and ask it first, but not now, actually, because we're going to take a break now, and we'll reconvene in about half an hour. And Steph is going to explain the rest of the afternoon to us, but we'll be meeting back later for the panel discussion and questions. So if you have questions for Meric, that will be your chance to put them at the panel time. Okay, Steph.
Thanks, Paul. Okay, so I will explain it just one more time, just in case, about how the next bit is going to work. At 4 o'clock, the online and in-person events are going to split into two separate panels. So online, we'll be speaking with Ruth and Hannah, and in person, we will have Ewan, Miriam, and Meric, who are going to answer questions in person. If you are online and want to ask questions to in person, please just pop them in the Zoom chat and we will try and put them to those speakers. If you're in person, please write down those questions on post-it notes in the foyer and we will make sure they are communicated to them. Both panels will be emailed out to everyone, so you'll have a chance to see both. That will be from 4 o'clock and will run till 4:45. At that point, we will be closing with a song and a prayer. And what would be really valuable, either now in the current break, but definitely before you go, online, please, can you fill in the feedback form? That link has been put in to the chat multiple times today, but I'm sure my online team will have it ready if I say the link now or very soon after I say that, I hope. And if you're in person, it's on the rolling slides. There's a QR code as well. But if you would like a hard copy, there are some on the table in the foyer as well. So we've got about just over half-hour break to get your questions in, to fill out feedback forms. And at 4 o'clock, we will reconvene for our final session. Thank you.